Good, then let's continue with SPM FMI pre-processing. So last time we wrote this function, which is not done, so we wrote parts of the function to do a standard FMI pre-processing of the checkerboard data that you are working on for your project report. And you remember that we did a little bit of data management or directory management, and then set up a for loop to do participant-specific data pre-processing, and created a subfunction that does the actual work. And there we got as far as actually setting up again the directories, removing things that might have been done before, so that we always start from a clean slate. I think that's how you say it. And before we wrote that, I showed you how you can easily create scripts based on SPM, so you don't have to go into all the details of SPM anymore like in the past, but you can use the batch editor to create scripts, and this is then where we want to continue today. Any questions about what we did last time or anything? No questions. Good. So the first thing, the first thing then that we want to do is to import the data, and you know that we are dealing in this case with PAREC files, because this data that you're working on for your project report was acquired on a Philips scanner in Berlin. If you're working with a scanner in Berlin, it's likely that you have the DICOM format, because here we primarily have Siemens scanners, but they need to be transformed to NIfTI nevertheless. So it's essentially the same step. So then let's continue here, and how do we do that? Yeah, so what we want to do is we actually want to keep the data separate over runs. And remember that we had, we have it actually here, we had 5 runs, and these were labeled 4, 5, 6, 8, and 9 in terms of PAREC. So for each of them, we now want to create a subdirectory, and then convert the PAREC data, put it into the subdirectory, and then use this data in the subdirectory for our subsequent pre-processing steps like realignment, normalization, and so on. So we are currently at the following status. So we have this folder structure where we have the behavioral data. This we actually want in the very future, but we don't have yet. We have the PAREC data in the PAREC folder, and we now want in the pre-processing folder, we want subdirectories for each run, and in there we want to save the data to be processed. So we just do that, and this is how we can do that. So we have data management, then let's do as a next step data import. And of course, there are different ways you can do that. You could now write a for loop that does the whole pre-processing for or one run, but we will do it really step by step because that's then clearest. So we will now create a for loop just for data import. So we iterate over our runs, and what I find helpful is to have iteration counters that have sometimes, most of the time, some meaning. So we use R to indicate run, and we go over all runs in our run dir variable. So that's this. So we can see whether this works. So let's run it. SPM so far. So remember, I commented this out, and I will again because this always takes up time during debugging, which you might not be willing to spend, because now it's adding stuff to the path and initializing SPM, which takes a little bit of time. But then at one point it went into our run of interest, and you see that, our for loop of interest, and you see that this works. So we can do this for loop over runs, and now I want to comment this out again so we don't have to wait all the time. Again. Anyway, we will see whether that works or not. Good. So we want to make a run. We want to make a for loop, or write a for loop over runs, and then the first thing is that we want to create a directory now in our pre-directory that is run specific. So let's say we first, so we do it step by step, we come up with a run directory name. Any suggestions what we should do to this end? To make this. Yeah, we have this directory already. So actually, yeah, I don't know. See, that's one thing is to do things interactively. The other thing is that it sometimes makes things more complicated than if I just tell you how to do it. So the run directory we can build based on the participant directory, which we have, which is this pre-directory. So this one, which is participant specific. And we now define the run directory name. Participant and run specific directory name. So we take our participant directory and then give it a name. So we have two options. We can call the runs 1 to 5, or we can call the runs as they were acquired. So 4, 5, 6, 8, 9. I would tend to keep it as 4, 5, 6, 8, 9 because then you don't get confused, or it might be less confusing. But these things are always one thinks about, and then it's confusing after all. So let's use this and then concatenate this with a run directory, which we call yes, this should work. Let's have a look. So whenever you program something, run it and check whether it works. Don't write a lot of code and hope that it will work, and then at one point run it and then, oh, it doesn't work. What have I done wrong? And then it gets quite hard to figure out what's we have done wrong. So that doesn't look too bad, but let's now also create participant and run specific directory. Of course, you could also do this in one step. I'm just trying to be as explicit as possible without using too much verbal stuff here. So let's see whether we have a bug somewhere. Do it. No. So now you see that these run directories were created, but of course they are empty because nothing has happened yet. At least we have some directories in which we now can put in our data. And then we use finally what we have created a long time, namely this thing here. So let's copy that. I don't want to do it this way. Conversion. And yeah, now the magic with this whole SPM programming is to then specify not as you click it there, but to make this kind of automatic. So I usually rename the whole variable job as job and not MATLAB patch, just because I do that. Then it's good to initialize this variable as the empty array, because then if you have something in your script already, it gets overwritten. So job structure initialization. And then we have to now specify what we actually want to convert. And this is then the biggest task in the whole thing of writing scripts, is to get the paths and file names right. So everything is easy, except this is also easy. This is just what takes time. So we have to define the parrec data file that we want to convert. I guess there's also an option to do multiple at one point, but we do it step by step. We have to define where we want to have it written, and we have to define in which format we want to have it. That's what we have to do. After all, we are research workers, which means we have to do some work. So that's .parrec file to convert. This is .ne file resulting from conversion. Or what? And this is already taken into account here. This is the file format. And so we've documented this. This is actually when you work with SPM, maybe another hard part next, like defining the file names and so on, because you don't get nice documentation of what these different fields are. You have to kind of make that up for yourself. But then in your own script, you can of course document that. Good, so we need to define the parec file to convert. So then let's see how we do that. Somehow I have to make it smaller, because I hardly see anything here. Oh, sorry, fonts. So, I see a little bit more. And you also see a little bit more. You can still read it, right? Good, so what we specified so far is 12DO, which is of course not a bits file name, but that's okay. And now we just have to build this, essentially this file name here based on what we have. And that's the big task. I mean, it's fairly trivial if you think about it, but apparently it's a big task. Otherwise, I wouldn't be doing this here. So let's see. This will not run, of course. Let's comment this out and see what we have here. So in .dir we have the whole directory, and so there we have everything up to here, and in .dir we have the participant name, so parec file name. Let's call it f name and do then full file .dir. No, .dir. Here. So this is now where we are, and then we know that there's this folder called parec, so we can specify that directly. You could have a variable that says parec, but this must be the structure for all participants if you write it like this, but yeah, that's how it is. Then you have this checkerboard DO, which is we have CB underscore, and then we have the last two of this. If you have bits format, this will look different, but you will have the same problems. So you have as put dear. How can I get, if I have as put dear, how do I get the last two characters? So how do I get the DO? This is just general method knowledge. Nothing to do with SPM. Any suggestions? How to do that easily without needing to account for the fact that sometimes maybe this put dear might have more than 5 characters? Come on, somebody knows that. Michael, now that you're here. But you are at Max Planck, and Max Planck people really know things.
Sure. I mean, it's a character or a string, so maybe something in this character array at position 4 and 5.
4 and 5, yeah. And how can you?
And we have to know that we need 4 and 5, and I'm not sure if this is the case right now.
No, exactly. So that's definitely the right thinking. So what we know is that these put dears always end on the initials. This is what we know.
Okay.
And what would
I
you?
don't know the answer.
Okay. So any other suggestions how we can do it? Then
use end in the minus too.
Yeah. And what exactly?
So end, and then -2, right? Until
yeah, Python and MATLAB.
Yeah, and then -2, yeah.
Not -2, -1. So end is just the last one.
Oh, right, yeah.
I mean, if we wanted this, we would do -2. But
yeah.
again, this kind of things, just by debugging, you learn them. So we need this. And then we need more. So we want to specify the Parec file name, right? So how are we doing there? CB, then we have this, then we have an underscore, then we have our run number. And here we need to make sure that this is actually the file name. Don't have to use num2string, or you can also use printf, but I'm lazy. Of course, for this run, and then there's some more stuff. _1, and this _1 is for all of the files, and then oops. So let's see how that looks. So if name, the very long location, fdo parec, and then cbdo _ path. Looks for the moment fine to me. Oh, that's the file name. So the whole path to here. And this is the only thing that is somehow, it's not even complex, it's just annoying in the whole analysis, especially the pre-processing of using SPM, so to get these paths right. So then we know the file name. Again, you don't need an extra variable for that, but I'm doing it here for educational reasons. So let's call it, let's put this in here. This is actually the output directory. But then it's also the Nifty file. So we want that, and of course, in the directory that we have just created. I can also call it target directory for file. And we have agreed that we want it as a Nifty file. And then what remains to be done is to call that job. There used to be different options, especially whether you want the GUI or not and so on. But I think these days that's not necessary anymore. And we just can specify like this. So what happens here, and this is always the same in the whole SPM programming business, is that you specify the job structure according to what you want to do. In this case, convert this parec file. You need to specify it in a way that SPM likes. If you do something wrong, it will not run, and then you just run it and hope for the best. Any questions?
Yeah, I wasn't here last week. Could you quickly say what job does? Is it a
this doesn't do it. No, this doesn't do anything. Oops, this is wrong.
Okay.
So this doesn't do anything. This is just the structure that is passed to SPM Jobman. SPM Jobman is an SPM function written by the Freiburg people that does the interaction between so not in the path. Oops. That does the interaction with the low-level stuff in SPM.
And low level, is that also MATLAB or C?
No, that's SPM. Low level is things like, I don't know what, I guess there's a function called SPM import. SPM. No. Convert. It's convolve. So there's some conversion functionality. I'm not quite sure what the function is called at this point that actually does that.
Okay.
Maybe it's also can also be C code, but this Jobman always interacts with these low-level functions, which sometimes, of course, also call MATLAB low-level stuff. Any other question?
You only called par files, not the rec files.
Yeah, so the par and the rec files, they always go together. So the parameter, if there's a parameter file for Philips, there's also a rec file. So the parameter file has the parameters and the rec file has the actual data. So that's sometimes what you find. The Nifty, I think, has everything in one. So that's, but if it's par, then par rec, then if you specify the parameter file, then it knows that it has to look into the rec file as well. And there was another question.
Yeah, so we are creating only one Nifty file, right? Because there's also the option to create the header, like separately.
so what I want to do is actually create this one Nifty file, which is a 4D file, and then separate this into 400 Nifty volumes. And I'm not sure whether you refer to the image header format. So we are not using the image, but we are not there yet, but we're not using the image header format, but the Nifty format. So image header, so this was what you also see a lot, is this image header format, which is the same thing as the parec in the, so there you have a header and there you have the actual image, and then you have many volumes, or do you have one volume? Many volumes, yeah. So there's still this dream about not having many volumes, but having a 4D file. But I think this dream has not really come true under SPN 12. What has come true is the thing that there are 4D files which we now create, and which are also actually the Nifty files that you create under bits. They are 4D files, meaning that the volumes are put together into one file, but then to actually analyze them, you still have to then split them again. And image header would, when we do the splitting, which we haven't done yet, would, instead of using Nifty, would use the image header format. I think it might be an option actually in the import, but I'm not sure.
I think so. In the import, that's why I'm asking here, because I think that is specified in the import, like with the blue.
So we do parec, and okay, and there you specify this. Yeah. Can do. Let's see whether that's maybe for DICOM, because maybe that's the only option for DICOM. Oh, but here you can also use a single Nifty file. You don't have to do header image.
So it's better to do the same.
Yes, then your results are right and you know how the brain works. I would actually, so the ideal world would be, and this is how it works in Brain Voyager forever, that you don't have these many files. So for each volume have a single file. This, what is annoying about this is not so much that you have that many files, but that it always, if it does something, it needs to write all these files. And to write on a hard disk and also to synchronize between different things, the problem is not so much to write and synchronize one big file. The problem is this accessing and again accessing hard disk space. So it's a little bit annoying. So, but on the other hand, you see always how many volumes you have, and you can do things like we have to throw away the first 3 volumes because our Siemens scanner does some dummy scans, and we are not quite sure whether it's actually 3 or 2. You can do these things manually then. So. Here we don't have to throw anything away because as bad as Philips scanners are, this is what they don't, this confusion they don't put on you. So let's see. So any other question right now? So let's see whether that works, at least for one run at first. And then also for the other ones. Usually if things go wrong, then exactly. Then something is horribly wrong, which is usually due to the paths or other things. And maybe we should also run this here. But I can also show you how you can check whether that's what you actually did wrong. No. So something is not working, and then it's also sometimes not easy to see what actually is unspecified. So to check what has gone wrong, unless you see it from this, what you can do is actually, I mean, this is really is to try to get what we set up in here into the SPM GUI to check what you actually and what we have here specified, because that's really not easy to debug sometimes. Usually it's path names, so it's if you don't know why it's not working, it's usually because the path is wrong, which I guess is also the case here, but let's see. Everything is wrong. This is, of course, these are these little things. So maybe we specified the path correctly. I'm not quite sure, but what we didn't do is to make it a cell string. We defined it as a path, string, but not as a cell string. So as you see here, it needs to be put as a cell array into that. Same for the output directory. This is actually also what it complains about here. I have a bias against reading what is happening here because it's usually not helpful. In this case, it would have been helpful. So we have to pass our arguments like this, because that's how SPM wants it to. So let's see whether we do better then. So now we have hopefully have a better version of that. So let's see again. So this is what I recommend to do the debugging, to investigate, especially if you're doing it this way, what you might not have specified, because then in the SPM batch editor you can easily see that. Oh no, load batch. So that looks better. So now you see that this is not empty anymore, but there's something specified, because that's what we specified in our script. There's also something specified, and this is also specified. You have to, the SPM expects things to be called MATLAB batch. So this is why I'm passing the job to MATLAB batch here. If it's called job, it doesn't realize it. But I think MATLAB batch is a little bit long. So in principle, the task manager, the batch manager of SPM says this can be executed. Let's see whether it actually will be executed. It looks better. Der ist der Kurs von Herrn Ostwald. So it's running something, it's doing something. Let's see whether we can observe it while it's doing it. Actually, yeah, so that has worked. Apparently my sync is on. I thought I turned it off, but I restarted. That's why it's on. I have to turn off my syncing here. Oh well, it's at least paused. So it did its thing. It says it's done, and this was for one run. So then let's see whether this works for all of our runs. So you, what you just saw is that it was emptied again. So whenever we run the script now, everything that will be there will be thrown away, which you should be aware, especially if you run scripts only step by step. Then you might need things that will be erased by these new directories. So we've done one, so now it's going to the second, and you can watch it work. So there's our Nifty. Here it's still converting. Might actually, no. Yeah, I think it's suppressing all the SPM GUI stuff by default now. There used to be a time when you run this via script that it will bring up the GUI, and then you see this thermometer thing, this red bar going up, but I think they removed that because nobody wants to see that. So I don't want to see it. I always feel a little bit sick. Good, so it's importing our stuff, which is good, and means we can have a break once we see that this has actually worked for all of them. Is there a question right now? No. Good, then let's have a break. It's doing its final stuff, and then we'll start again shortly before 11 to then split up the one Nifty file and then do some realignment.